Hey everyone, welcome back to Whatever, and this is Jake here, where we literally talk about whatever. Today is another James Webb Space Telescope update. James Webb Telescope's new discovery left scientists speechless. I know they always get me with this, but I always learn something new. It's great. Go check them out. This is Voyager. Voyager put this out pretty recently, not 9 minutes ago. I think it was like 20 some hours ago, but I just saw it. I haven't seen the video, but I just saw it pop up and I figured I'd do a video and update so that way I can learn something. Hopefully you can learn something. And, I mean, that's just more knowledge, more knowledge. So, if you enjoy videos kind of like this, then just let me know down in the comment section. Also, before I started, I got a comment on the last video and I was like, no, this guy makes total sense. He was he was saying that I did a reaction to Ren, and then I put one of the cards up was a link to the Pokemon pack opening. I know that's not really structured and it doesn't really relate, but it was just kind of like that was my most recent video, so I just put it up there. So I don't know if y'all are if y'all really care about that kind of stuff as far as maybe relating the videos as they pertain to whatever I'm doing. Like this one, I could link it to the last more kind of segment, or you don't really care and it's just kind of like you don't even really click them anyway. But I thought it was really funny, and if that's something that is a thing, I guess just let me know and I'll 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 put the video cards to something that relates to the video itself, or a video that I've done recently. So yeah, just let me know in the comment section as we start this, okay?
It sees this distortion in the fabric of space and time, and it curves in response to it. Einstein predicted this.
We designed this
Damn.
telescope to see the very first galaxies that turned on in the universe, and when we saw what it did, whatever's out there, we're going to see it.
NASA is looking into distant planets, but when will they reveal the universe's exoplanet's true nature? No telescope has ever discovered carbon dioxide in the atmosphere of an exoplanet. However, a groundbreaking discovery by the James Webb Space Telescope that will usher in a new era of research is the detection of carbon dioxide in an exoplanet's atmosphere. Is its fleeting resemblance to the solar system concealing alien planets with inhospitable conditions? Can there be life on planets?
That's a scene like out of a movie or a TV show. It's got to be. I mean, that like they could just wipe us out with something like that. They could wipe us out in like a heartbeat. Our nuclear weapons won't do. We wouldn't even be able to arm them and press the button, much less, I don't know. Anyway, I've had dreams about this kind of stuff. All right.
Other than our own? Or do we inhabit the only universe? Let's find out. The TRAPPIST-1 star, which is only 39 light-years away from Earth and a close neighbor
Holy.
in the cosmos, is not like the Sun. The star has a mass of about a tenth of that of the Sun and is roughly the same width as Jupiter. But what really excites exoplanet hunters is what circles it. The Transiting Planets and Planetesimal Small Telescope TRAPPIST, a Belgian telescope at La Silla Observatory in Chile, made 3 planet discoveries in 2016. The now retired Spitzer Space Telescope from NASA more than validated the discovery in 2017. The TRAPPIST-1 system was discovered by the Spitzer Space Telescope, and JWST is the follow-up. And during that time, astronomers have been gathering as much information as they can about the 7 TRAPPIST-1 worlds. According to a 2018 study, its planets are rocky and some of them may be wetter than Earth. They were most likely rocky, though less dense than the planets in our solar system, according to the research published in 2021. The solar system and the TRAPPIST-1 system are most likely very different. All of the planets orbit their star closer than Mercury does the Sun, despite the fact that 4 of the 7 planets are in the habitable zone of their star, close enough to be warm enough to support liquid water. It may not have much of an impact on temperatures given how much fainter the star is than our Sun, but it has a significant impact on the planet's environment. For instance, TRAPPIST-1b, the nearest planet, completes an orbit around its star every 1.9 days. That year,
You imagine that? Every 1.9 days, it's like, all right, well, you're just constantly thinking about a birthday. Uh, I'm the only one. I'm probably the only one that is ever gonna think that, but whatever. That'd be or some other form of measurement for your birthday, because 2 days. I mean, you'd be 1,000 years old in less than a couple of years.
year was incredibly brief. A year on the furthest planet, TRAPPIST-1H, lasts around 19 days. Additionally, all of the planets are probably tidally locked,
Oh, like
similar
2.5.
to how the Moon is to Earth, so only one side is ever illuminated by the Sun. Despite these variations, TRAPPIST-1's diversity of rocky planets makes it the top exoplanet target for the JWST. Furthermore, despite being one of the most researched planetary systems, researchers believe TRAPPIST-1 still holds many mysteries. Can JWST learn what these 7 rocky exoplanets' atmospheres contain? Because of the near-spec sensor aboard Webb, it's the only telescope that can recognize signals of molecules like methane, carbon dioxide, and oxygen, potential indicators of surface life, and hints about the composition of a planet's atmosphere. According to NASA, the James Webb Space Telescope has discovered definitive proof of carbon dioxide in the atmosphere of a planet outside of our solar system. Future research on smaller planets could benefit from these groundbreaking findings, which could offer valuable insights into the composition and genesis of the planet. The discovery was made as part of the first exoplanet campaign of the James Webb Space Telescope. Exoplanets are planets.
Look at that picture. That's like, I don't know if anybody here has watched Futurama, but like Zap Brannigan told Kip, he's like, enhance that image. And as it gets closer, it gets grainier. And he's like, what? He's like, what's going on? And he's like, just because you zoom in doesn't make it any clearer. He's like, it does on CSI Miami. So yeah, no, CSI is not real. That's not a real thing. All right. It may be entertaining, but that's what you get when you zoom in, especially on these telescopic images.
The orbit of the stars. The observations focused on WSP-39b, a hot gas giant, which is 700 light-years from Earth in the constellation Virgo. With an orbital period of roughly 4 Earth days, WSP-39b orbits its parent star,
Man, that'd be a nightmare.
WSP-39, very closely, less than 1/20th the distance between Earth and the Sun.
God.
The planet was found in 2011 and can only be seen during transits, which are small dips in the star's brightness that it makes around WSP-39. The planet had been previously seen by the Hubble Space Telescope in optical wavelengths, and the now-retired Spitzer Space Telescope, which, like Webb, observed heat-carrying infrared wavelengths. The planet is about as massive as Saturn, but larger than Jupiter in size. Water vapor, sodium, and potassium were detected in the planet's atmosphere in earlier investigations.
How did they detect these elements? Like, I don't know if infrared is there for that particular purpose. Are there maybe the different colors mean different things? I'm not really positive how they detect exactly which elements or compounds are on the planet. That's the one thing I haven't really wrapped my brain around. If anybody has any information on it, just let me know in the comment section. I'm obviously not the expert. I'm learning. So, yeah.
But it wasn't until Webb that carbon dioxide signal was detected. There has never been any evidence of carbon dioxide on an exoplanet. But according to experts, the molecule may be able to contribute to their understanding of the planet's evolution and formation history. A significant step in characterizing the atmospheres of exoplanets has been made with this clear detection of carbon dioxide. Carbon dioxide, which is particularly sensitive to the conditions in the disk where the planet formed, enables us to measure total carbon and oxygen inventory of the atmosphere. These observations can help establish the planet's formation distance and how much solid and gaseous material it gathered throughout its migration to its present location. Using Webb's NIRSpec instrument, a very sensitive spectrograph that divides incoming lights into barcode-like spectra that show how the examined objects absorb light, the discovery was made. Researchers...
So how they absorb light, that's how they differentiate. Like he was saying, like the barcode. I think that's what that means. Let me know if I'm right or wrong about that assumption.
Compare measurements of the star's normal light to light seen through the exoplanet's atmosphere when it passed in front of it, instead of using Webb or any other existing telescope to take direct photographs of the exoplanet or its atmosphere. According to the experts, the telescope will be able to spot carbon dioxide in the atmospheres of many planets, including rocky ones like Earth that are dispersed around the galaxy. On the other hand, as the James Webb Space Telescope focuses on exoplanetary atmospheres rich in vaporized rock and crystals like corundum and perovskite, which create gems on Earth, astronomers will be hoping for gloomy skies. Gas giants known as hot Jupiters, which orbit their stars very closely, become so hot that rocky elements, minerals and metals can exist in their atmospheres as a vapor after being burnt by temperatures as high as 3,600 degrees Fahrenheit. That's 2,000 degrees Celsius. Many of these minerals are precious gems on Earth. On Earth, a geologist would analyze them as rocks, but on exoplanets, they can form clouds. That's quite bizarre. These minerals have previously been found in the atmospheres of exoplanets. Titanium oxide was found to have a distinctive signature in the atmosphere of a hot Jupiter dubbed WSP-19b in 2017, according to astronomers using the Very Large Telescope VLT at the European Southern Observatory in Chile. 3 years later, the VLT discovered iron vapor on the hot Jupiter WSP-76b's day side. The fact that many hot Jupiters are tidally locked or always present the same face to their star causes their day sides to heat up tremendously. The dayside temperature on WSP-76b reaches a sweltering 4,000 degrees Fahrenheit. That's 2,200 degrees Celsius.
God.
Only 2,700 degrees Fahrenheit or 1,500 degrees Celsius on the planet's night side. Yet that's still low enough for iron to condense and precipitate out as a rain of molten metal. These substances and minerals have previously been found in exoplanetary atmospheres in a diffuse form. Now, by directly distinguishing these minerals as clouds and spectroscopically analyzing their makeup, JWST's high-resolution vision will be able to. The exoplanet WSP-96b's atmosphere features water clouds, which were previously considered to be absent, according to JWST observations of extraterrestrial atmospheres. JWST is also studying a wide range of different exoplanet atmospheres during its first year of observations. The JWST will also study the atmospheres of more compact, rocky exoplanets. The super-Earth 55 Cancri E, which has 8 times the mass of our planet, will have its atmosphere's composition measured by researchers. They hope to find out whether the super...
Man, you gotta have to forgive me for all. I mean, my sinuses were kicking my butt. So it makes me like kind of itchy, and my nose is kind of runny. Even my nose gets kind of itchy. I'm itchy sometimes because of it, but
Earth is hot enough to produce lava rain, and JWST will examine the 7 planets in the TRAPPIST-1 system, checking each one for an atmosphere as it scans the system. TRAPPIST-1e, the neighborhood planet with the closest resemblance to Earth, will be the focus of special studies from astronomers. If it is livable, then its atmosphere, especially its clouds, might provide proof of such. On Earth, clouds play a crucial role in controlling temperature. They have a significant role in determining Earth's climate. It makes sense that clouds might also have a key role in the composition of an exoplanet's atmosphere. The more we learn about how clouds generally form, as they have on Earth and other planets in the solar system, the more we learn about how clouds have evolved in more unusual environments. Meanwhile, the James Webb Space Telescope started its year by confirming an exoplanet after a breathtaking initial batch of photographs last year,
Ooh, that's
including
nice.
those of the birthplaces and deathbeds of stars and the cosmic waltz of galaxies. The exoplanet, officially known as LHS 475b, is nearly the same size as Earth, measuring 99% of our planet's diameter. Planets outside of our solar system are called exoplanets. Some of these planets are free-floating and orbit the galaxy's center, while most of them orbit other stars. The first actual exoplanets or extrasolar planets were discovered in the 1990s, despite the idea of these planets having existed in theory and science fiction for centuries. A pulsar, which is the dense remnant of a dead star that emits pulsating beams of light while...
Now that's interesting. They were talking about they were existing in theory for centuries, but then sometimes, like, if you've ever seen some of those videos where they have texts from back in the day where they, like, these people, I like, see, I don't know, I think it's true. That's just me because of all the stuff that's been happening recently and like all the stuff they continue to find that, like, you know, people have come from somewhere else. Not maybe not humans, but like other beings have come from somewhere else, or maybe they've taken us somewhere else. I don't know. Maybe not us specifically, not me specifically, but somebody. I don't know. Unless some of these people were on some crazy drug and they were tripping and they went on like some like acid, like some equivalent of acid, and they were, or maybe they were astral projecting. I have no idea. That doesn't seem far fetched to me. All right, just put my little tinfoil hat on, but I don't know. It's just crazy to me to think that they would write that stuff in old texts and old hieroglyphs and all that other stuff. But
rapidly rotating, was discovered by two astronomers in 1992. The pulsar was located about 2,000 light-years away. Then, in 1995, two scientists discovered the first exoplanet circling the star 51 Pegasi, which is similar to the Sun. This exoplanet was a hot gas-rich giant that orbited its home star, a type of exoplanet known as a hot Jupiter. The orbit of this exoplanet was closer to its star than that of Mercury and the Sun. Astronomers estimate that there are an average of one exoplanet for each star that can be seen in the night sky. And more than 5,000 exoplanets have been discovered to date, according to NASA. Proxima Centauri b, the closest exoplanet, orbits a red dwarf star some 4.25 light-years away, 1 light-year, of course, being equal to 9.46 trillion kilometers. Exoplanets have so far been found by both ground and space telescopes using various techniques, and they range in size, mass, composition, number of planets in a planetary system, or the number of stars the planet orbits. These exoplanets range in composition from being rocky, like the Earth or Venus, and gas-rich, like Jupiter or Saturn, to even having a density similar to that of styrofoam, or being covered in molten oceans of lava. Exoplanets frequently share components with planets in our solar system, albeit in different proportions. For instance, some may have more carbon or water. Exoplanet features not only provide information on their formation, evolution, and potential presence of life elsewhere in the universe, but also aid in our understanding of our solar system. For instance, certain exoplanets could not have formed as near to their parent stars as they are currently based on their compositions, indicating that they must have closed in later, demonstrating that planets can travel from their sites of formation. What do we know about the brand new...
so he's saying that they formed outside of, they moved closer and they couldn't have formed the way that they formed if they were further away, being where they are right now, right? That's what he said. I know there's such a thing as rogue planets, so I don't know if anybody knows if there's like an instance where like maybe that star or whatever has adopted a rogue planet and it's just fallen into orbit somehow. Is that another possibility, or is that totally way off? I don't know if that's outside the realm of possibility.
New exoplanet that JWST has confirmed. A rocky planet in the Octans constellation, LHS 475b, is located relatively nearby, at a distance of about 41 light-years. The existence of a new exoplanet was suggested by data from a NASA study of space conducted earlier called the Transiting Exoplanet Survey Satellite, TESS. Although JWST evidence indicates that this is a terrestrial planet the size of Earth, it is not yet known if it has an atmosphere. However, because of the telescope's sensitivity, the scientists are aware of the types of atmospheres that may be ruled out. They also suggested that an atmosphere made entirely of carbon dioxide might exist. The new exoplanet is a few hundred degrees warmer than Earth, according to the JWST.
Only a few hundred.
The scientists think that if clouds are found in this summer's studies, it may be a sign that the planet is more like Venus, which has a carbon dioxide atmosphere and is encircled by thick clouds all the time. Scientists have just begun to scrape the surface of what extraterrestrial atmospheres might look like with this discovery by the Webb telescope. The potent Webb telescope will be used by planetary scientists to study the atmosphere of smaller, rocky, Earth-sized planets. Who can say what they'll discover? Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about...
Well, there you go. There you have it, folks. That's pretty neat. To me, it is pretty neat. I hope you learned something. I know I did. And there's some stuff that's still a big question mark in my head, but hopefully some of y'all will watch the video all the way through and can answer some of the questions that I had throughout the video. Just click on one of these well, maybe just one card. I'll maybe just put one on there. Up above my head or over here in the corner. I can't remember which side it is. And I just wanted to cover this. I don't know if I covered this in the very beginning, but one of the commenters said, you know, hey, you need to, your cards need to be more relevant. So let me know down in the comment section if that's what you want also. All right. I enjoyed it. I hope you did. And as I always say, till next time, send it.